Cooking is much more than just preparing a meal. It's a fascinating interplay of chemical reactions that transform raw ingredients into delicious dishes. Every time you cook, you're orchestrating a series of changes at the molecular level. From browning meat to baking bread, these reactions are responsible for the flavors, textures, and colors we love. In this video, we'll explore the key chemical processes that happen in your kitchen and how they impact the food you eat. Let's dive into the science behind cooking and discover how understanding these reactions can help you become a better cook. You apply heat to food, molecules start moving faster, triggering a cascade of chemical reactions. Heat is the driving force behind many transformations in cooking, from softening vegetables to browning meat. As temperature rises, bonds within molecules break and new ones form, creating entirely new substances. This is why raw ingredients look, taste, and feel so different after cooking. Understanding how heat affects food is fundamental to mastering the art of cooking, as it allows you to control texture, flavor, and appearance. One of the most important reactions in cooking is the Maillard reaction. This occurs when proteins and sugars in food interact under heat, producing complex flavors and aromas. It's responsible for the rich brown color you see in grilled meat, toasted bread, and roasted coffee. The Maillard reaction not only enhances taste but also creates appealing visual cues that signal deliciousness. By controlling temperature and cooking time, you can maximize this reaction and elevate your dishes to new heights. Caramelization is another common reaction in cooking, especially when working with sugars. When sugars are heated, they break down and form new compounds, resulting in a sweet, nutty flavor and a golden brown color. This process is what makes caramel sauce, baked goods, and roasted vegetables taste so irresistible. Caramelization requires careful control of heat to avoid burning, but when done right, it adds depth and complexity to both sweet and savory dishes. Proteins undergo dramatic changes during cooking. Take eggs, for example. When heated, the proteins unfold and then bond together in new ways. This process, known as denaturation and coagulation, turns a runny egg into a firm, solid one. The transformation is not just about texture, it also affects the flavor and nutritional value. Understanding how proteins react to heat helps you cook eggs perfectly, whether you're making scrambled eggs, omelets, or custard. Denaturation and coagulation are key concepts in cooking proteins. Denaturation refers to the unfolding of protein molecules when exposed to heat, acid, or mechanical action. Coagulation is the process where these unfolded proteins bond together, forming a new structure. This is why cooked eggs, meat, and dairy products change from soft to firm. Mastering these processes allows you to achieve the desired texture in your dishes, from tender meats to creamy custard. Starches also undergo their own transformation during cooking. When heated with water, starch granules absorb water and swell, a process called gelatinization. This reaction thickens sauces, soups, and gravies, giving them a smooth, creamy texture. Gelatinization is essential for making foods like pudding, pie filling, and even bread. By understanding how starches behave, you can control the consistency and mouthfeel of your recipe. Gelatinization is the process that turns liquid mixtures into thick, stable foods. As starch granules heat up and absorb water, they expand and burst, releasing molecules that bind with water. This creates a gel-like consistency, perfect for sauces and desserts. The temperature and amount of water used are crucial for achieving the right texture. Gelatinization is a fundamental reaction in many recipes, from gravy to custard. Acids and bases play a significant role in cooking. Ingredients like lemon juice, vinegar, and baking soda can change the color, texture, and taste of food. Acids help tenderize meat, keep vegetables vibrant, and balance flavors. Bases such as baking soda can neutralize acids and affect the rise of baked goods. Understanding how acids and bases interact with other ingredients allows you to fine-tune your recipes for the best results. Acids are often used to tenderize tough cuts of meat. When meat is marinated in lemon juice or vinegar, the acid breaks down proteins, making the meat softer and more flavorful. This process also helps preserve color and enhances taste. Using acids wisely can elevate your dishes, ensuring that meats are juicy and vegetables are bright and appetizing. Acids can also help preserve the vibrant color of vegetables during cooking. Adding a splash of lemon juice or vinegar to boiling water prevents vegetables from turning dull or brown. This reaction keeps your dishes visually appealing and appetizing. The right balance of acid ensures that vegetables retain their natural color and texture, making them more enjoyable to eat. Fermentation is a crucial chemical process in cooking. Microorganisms like yeast and bacteria break down sugars to produce substances such as carbon dioxide, alcohol, and acids. This process is responsible for the rise of bread, the tangy flavor of yogurt, and the preservation of pickles. Fermentation not only improves taste but also enhances nutritional value and shelf life. Understanding fermentation allows you to create a variety of foods, from sourdough bread to kimchi. Yeast is a microorganism that plays a vital role in bread making. When yeast consumes sugars, it produces carbon dioxide gas, which causes dough to rise and become airy. This fermentation process also creates unique flavors and aromas in bread. By controlling the amount of yeast and fermentation time, bakers can achieve different textures and tastes, from crusty baguettes to soft sandwich loaves. Bacteria are essential for making yogurt and other fermented foods. They break down lactose in milk, producing lactic acid, which thickens the milk and gives yogurt its tangy flavor. This process also increases the nutritional value by adding beneficial probiotics. Fermentation with bacteria is used in many cuisines to create foods like cheese, sauerkraut, and kimchi. Pickling is another form of fermentation that uses acids and bacteria to preserve vegetables and develop their tangy flavor. The process involves soaking vegetables in a brine solution, where bacteria break down sugars and produce acids. This not only extends shelf life but also adds a distinctive taste to foods like cucumbers, onions, and peppers. Baking is a precise chemical experiment. Ingredients like baking soda and baking powder react with heat or acids to release carbon dioxide gas. This gas forms bubbles in the dough, causing cakes and breads to rise and become fluffy. The balance of these ingredients is crucial for achieving the right texture and volume in baked goods. Understanding the chemistry of baking helps you create perfect cakes, muffins, and breads every time. Baking soda and baking powder are both leavening agents, but they work differently. Baking soda requires an acid to activate, while baking powder contains both acid and base, reacting when exposed to moisture and heat. Using the right leavening agent ensures your baked goods rise properly and have the desired texture. Understanding their differences helps you choose the best option for each recipe. Release of carbon dioxide gas is what makes cakes and breads rise. When baking soda or baking powder reacts, it produces bubbles that expand in the dough. This creates a light, airy texture in baked goods. Controlling the amount of leavening agent and the baking temperature is key to achieving the perfect rise and crumb structure. Understanding chemical reactions in cooking allows you to control the flavor of your dishes. By adjusting heat, acidity, and ingredient combinations, you can enhance or balance tastes. Whether you want a rich, savory flavor or a sweet, tangy note, mastering these reactions gives you the power to create meals that delight the palate. Chemical reactions are responsible for the texture of cooked foods. From the crispiness of fried chicken to the creaminess of mashed potatoes, these reactions determine how food feels in your mouth. By understanding the science behind texture, you can achieve the perfect consistency in every dish, whether it's crunchy, chewy, or smooth. Color of food changes dramatically during cooking due to chemical reactions. Browning, caramelization, and acid-base interactions all contribute to the visual appeal of dishes. These changes signal doneness and enhance the attractiveness of meals. By mastering color changes, you can make your food look as good as it tastes. Cooking is essentially a series of experiments. Each time you try a new recipe or adjust ingredients, you're testing how chemical reactions affect the outcome. This experimental approach allows you to discover new flavors, textures, and techniques. Embracing the science of cooking turns meal preparation into a creative and rewarding process. Precision is key in cooking, especially when dealing with chemical reactions. Accurate measurements, timing, and temperature control ensure that reactions occur as intended. This is particularly important in baking, where even small changes can affect the final product. By being precise, you can consistently produce high-quality dishes. Balancing ingredients is crucial for successful chemical reactions in cooking. The right proportions of proteins, sugars, acids, and bases ensure that reactions produce the desired flavors and textures. Experimenting with ingredient ratios allows you to customize recipes and achieve the perfect balance for your taste preferences. Temperature control is essential for managing chemical reactions in cooking. Different reactions occur at specific temperatures, so knowing when to increase or decrease heat is vital. Proper temperature ensures that food cooks evenly and achieves the right texture, flavor, and color. Mastering temperature control is a hallmark of skilled cooks. Timing is another critical factor in cooking chemistry. The duration of heat exposure affects how reactions progress and the final outcome of your dish. Overcooking or undercooking can lead to undesirable textures and flavors. By paying attention to timing, you ensure that chemical reactions produce the best possible results. The quality of ingredients plays a significant role in chemical reactions during cooking. Fresh, high-quality ingredients react more predictably and produce better flavors, textures, and colors. Choosing the best ingredients ensures that your dishes are both delicious and visually appealing. Recipes are essentially instructions for managing chemical reactions. Each step from mixing to heating is designed to trigger specific changes in the ingredients. By understanding the science behind recipes, you can follow them more effectively and even adapt them to suit your preferences. Experimenting with flavors is a fun way to explore chemical reactions in cooking. By combining different ingredients and techniques, you can create unique taste experiences. Understanding how reactions work allows you to innovate and develop new recipes that surprise and delight. Innovating with texture is another way to use chemical reactions in cooking. By manipulating heat, moisture, and ingredient ratios, you can create foods with surprising textures, from crispy chips to silky custards. Understanding the science behind texture opens up endless possibilities for culinary creativity. Flavor pairing is based on the science of chemical reactions. Certain ingredients complement each other because their molecules interact in ways that enhance taste. By understanding these interactions, you can create dishes with harmonious and balanced flavors. The tools you use in the kitchen can affect chemical reactions. Different materials conduct heat differently, influencing how food cooks. Using the right tools ensures that reactions occur evenly and efficiently, helping you achieve the best results. Moisture is a key factor in many chemical reactions during cooking. Water helps dissolve ingredients, conduct heat, and trigger reactions like gelatinization and caramelization. Managing moisture levels is essential for achieving the right texture and flavor in your dishes. Air plays a role in cooking chemistry, especially in baking. Incorporating air into dough or batter creates bubbles that expand during baking, resulting in light, fluffy textures. Techniques like whisking and folding help introduce air, making baked goods more appealing. Emulsification is a chemical process that combines two immiscible liquids like oil and water into a stable mixture. This reaction is essential for making sauces, dressings, and mayonnaise. By understanding emulsification, you can create smooth, creamy textures in a variety of dishes. Enzymes are proteins that speed up chemical reactions in food. They play a role in processes like tenderizing meat, ripening fruit, and breaking down starches. By harnessing the power of enzymes, cooks can enhance flavor, texture, and nutritional value. Enzymes are responsible for the ripening of fruits and vegetables. They break down complex molecules into simpler ones, changing texture and flavor. Understanding how enzymes work allows you to control ripening and improve the quality of your produce. Tenderizing meat involves both chemical and mechanical processes. Acids, enzymes, and heat all contribute to breaking down tough fibers, making meat softer and more enjoyable. By combining these methods, you can achieve perfectly tender results every time. Chemical reactions in cooking can affect the nutritional value of food. Some reactions increase the availability of nutrients while others may reduce them. By understanding these effects, you can choose cooking methods that preserve or enhance nutrition. Preservation techniques like fermentation, pickling, and drying rely on chemical reactions to extend the shelf life of food. These methods not only prevent spoilage but also create unique flavors and textures. Understanding preservation chemistry helps you keep food fresh and delicious for longer. Safety is important when dealing with chemical reactions in cooking. Proper handling of ingredients, accurate measurements, and attention to temperature prevent accidents and ensure food is safe to eat. By following safety guidelines, you protect yourself and your family while enjoying delicious meals. Cooking is both an art and a science. The creativity of combining flavors and textures is guided by the principles of chemistry. By understanding the science behind cooking, you can express your creativity and consistently produce amazing dishes. Learning about chemical reactions in cooking empowers you to experiment and innovate in the kitchen. The more you understand, the more confident you become in trying new techniques and recipes. Embracing cooking chemistry opens up a world of culinary possibilities. Let's recap the key chemical reactions in cooking. Maillard reaction for browning and flavor, caramelization for sweetness, denaturation and coagulation for protein changes, gelatinization for thickening, acid-base interactions for taste and texture, fermentation for rising and preservation, and leavening for fluffy baked goods. Each reaction plays a unique role in creating the food we love. Cooking is a journey through chemistry where every meal is shaped by fascinating reactions. By understanding and mastering these processes, you can create dishes that are flavorful, beautiful, and nutritious. Whether you're a beginner or an experienced cook, embracing the science of cooking will elevate your skills and make every meal a memorable experience.